Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now in this video I am going to explain numerical application in chemical kinetics. And here there are so many concepts in the chemical kinetics and different type of formulas are there. How we will use numerical application. So first of all you will see different type of concept and formula. Now here see, this is introduction part 1. First we should know what is chemical kinetics. Chemical kinetics means here the study of reaction rate and their mechanism. That means reaction rate you will see what is meant by reaction rate and their mechanism. Rate of chemical reaction. Actually what is meant by rate of chemical reaction? The reaction rate. Reaction rate means there is some change in molar concentration and with time. That means if you take that is a reactant, that is let it is example R, then what happens here? Here you will see if R is the reactant and a chemical reaction takes place gives product P, that means here there should be change in molar concentration in R also and P also. That means molar concentration in a reactant decreases and molar concentration in product increases. Then what is rate of reaction? How can you explain in mathematical? That means here you see minus delta, that is concentration, molar concentration R, and here plus del, that is P delta T. That means divided by delta T. Here what is mean? That means the concentration of R, here what happened? That is having minus sign and with time T. So what is meaning? Negative. What is meaning? Negative mean there is a sign of negative in that is molar concentration of R. It has no mathematical value. It is only indicates that the concentration here decreases. If you say plus sign, then here the P is product. Molar concentration of product increases. Increases mean what? That mean here there is a positive sign. And if you see graph, then in graph what it indicates? The concentration of concentration of reactant decreases and concentration of product increases. See this side, if you observe this side, what happened? The concentration is full at the time T0, if origin is 0, and when the time increases the concentration of product that is increases. And here what is this one? R, concentration of R decreases and concentration of product increases. Then what is average rate? If you know with the time, a different interval of time, then what is the rate? If you say take average, that is called average rate. So decrease in concentration of R and time taken, and similarly increase of concentration of R, P. Increase the concentration of P, decrease in concentration of, or you can say increase the rate in concentration of P, decrease in rate in concentration of R. Again see, decrease in concentration of R. Then here decrease in rate. Here you can write here increase rate mean here also write decrease in concentration. Here decrease in concentration rate, decrease in rate in concentration of R. So after that you will see what is meant by instantaneous rate. Instantaneous means at particular time. Suddenly you want to see what is the rate. That means rate of change of concentration of any reactant or product. Change in concentration I told, in reactant that is decreasing, in product it increasing. That means at particular moment of time we will check then that is delta T tends to 0. So if the product is P and reactant is R, then what happen here? You can observe delta T tends to 0. So it tends to, that means minus D. D is very in small change. That is very small change, that is small d. D are concentration, molar concentration by dt. Similarly, if you say delta T tends to 0 and that is plus dp by dt, that is called very small change, that is called instantaneous rate, also instantaneous reaction, or lastly you can say instantaneous rate. This is the minus dr by dt minus plus dp by dt. You know how we will use minus and negative and positive sign. Suppose a general reaction, general expression for a general expression is there. How can you calculate instantaneous rate? Instantaneous rate means, suppose the reaction AA, BB, and that gives CC, DD. That means AA, BB gives, both will combine, it gives CC, DD. What is here? It indicates here the number of moles of A, the numbers of moles of B, the number of moles of C and D. Here what is meaning? How can you calculate rate? Here you observe small a is there. Small a means what you will do? Minus 1 by A. What is minus? Minus means decreasing concentration. So that is for reactant, you should give a minus sign, negative sign. So B means 1 by B, and it is minus sign because it is also reactant. Similarly, C is there, small c is there. If this is small c is there, you write plus 1 by C, dc by dt. That means what indicates? Plus means increase in concentration of the product. Similarly, plus 1 by D, here D means small d, D means molar concentration of D by dt. What you are sure that if general reaction, minus sign always for the reactants and plus sign always for the product. Now here AA, moles of small a, and if that is moles is indicating that you should write in rate 1 by that mole. 1 by that mole. Suppose capital A, that is a reactant, and small a, that is mole. Then calculation of reaction rate, see, this is the general expression. From that you see for a particular reaction 3s2 plus n2 arrow mark 2 n. What is the meaning? This is a balance equation. This is one a balance equation. In this balance equation, how to write rate? See, 3 is there, minus 1 by 3. And ds2 by dt. N2, that means nothing is there, that means it is 1. So minus dn2 by dt. If both are reactants, then come to product. Product is 2ns3. So what you will write? Plus half. Plus 1 by 2. Then dns3 by dt. This is called rate of a chemical reaction. In terms of instantaneous rate, this is called instantaneous rate, and this is one example. Second example, you can see 2HI arrow mark S2 plus I2. What it indicates? HI is the reactant and S2 and I2 they are product. 2HI, what to write? Minus 1 by 2. And here S2, there is no other digit, simply, so plus ds2 by dt, and here plus d I2 by dt. That means you are sure that minus 1 by 2 for reactant and plus 1 ds2 by dt and plus di2 by dt. So calculation of reaction rate, that means same you will write, and HI here rate is same. And here what happened, you will check the new one, that is word that is called rate law. What is rate law? It is a mathematical expression. In 11th class also you read law of mass action. From that it is taken out, and in which reaction rate is given in terms of molar concentration of reactant. Remember, this never depends on the molar concentration of product. It only depends on the molar concentration of the reactant. If you know that mean molar concentration properly, then rate proportional to A to the power X, B to the power Y. A means molar concentration of A, B means I want to say molar concentration of B, X. Why you are writing X and why not A, B? Because here also it indicates moles of A, moles of B. You can write B small b, but not Y. Actually, this X and Y, this X and this Y, they are only calculated from the experimental value, is determined from the experiments. So the value of X and Y maybe it equal to X equal to A and B equal to that means Y, but may or may not, that it is not sure, but from experiment this value is correct, and after that you can check, yes, X is equal to A, yes, Y equal to B, or may not equal to A and B. So here if you write rate proportional to this one, and then what is this one mean? Molar concentration of A to the power X, molar concentration of B with the power that is here Y. So if you take equal to, then what happen? You put a constant that is called rate constant. What is that called? Rate constant. So the value of X and Y determined from the experiment. Then what is order? When you know what the powers raised to the molar concentration of reactants, and that power may or may not equal to the moles of the reactants, this is that is calculated from the experiment. And if you know what is the value that is above that molar concentration, if the sum you will calculate, that is called order of reaction. That is called order of reaction. Sum of the powers raised to the concentration concentration terms in the rate law. Then here rate equal to, if it is zero order, then how can you know? Rate equal to K molar concentration of A to the power 0. 0 means here 0 order. Here what is that one? 0 order. Similarly, if you say molar concentration of A to the power 1, then it is called first order. Similarly, molar concentration to the power 2, that is second order. Similarly, 3, then third order. That means how can you write here? Rate equal to K A to the power 0, and this one is K, that is 0 order rate constant. So you can write here also 0, and here if you write K, you can write also here 1. That means this is rate constant for the first order. If you write here 2, then rate constant for the second order. If you write 3, then it is rate constant for third order. So I think it is clear to you. The rate that is equal to rate constant, and molar concentration of the reactant to the power some digit, some term, some numerals. So, and that is called order. 0, 1, 2, 3. These are called 0 order, first order, second order, and third order respectively. Then first you will see what is mean by 0 order. 0 order mean, here what happened? It never, the rate of reaction is proportional to the 0 power of the concentration of the reactant. But important, if you come to a numerical problem, something to the power 0, that value come to, in mathematics, numerical value is come to 1. But when you simply see what is meaning of a 0 here, this is 0 order. That means here the rate of reaction proportional to the 0 power of the concentration of the reactant. How can you see the integration value, integrated value? If you say for 0 order reaction, if you say R proportional to, R arrow mark P, that means R is the reactant, P is the product. Then what is rate? Rate equal to, I told just now, rate equal to K R to the power 0. Or you can say rate This one, what is rate you know? Minus d, that is instantaneous rate I told, dr by dt. Then you make equal. So suppose this is the equation 1 and it is equation 2, then it is equation 3. In equation 3 you make equal. Then here I told in mathematics what happened, anything and to the power 0 means this value is equal to 1. So what is minus dr by dt? That is equal to k. Are you clear? Then if you take k to side time dt, then what is the meaning here? D, a molar concentration of R equal to minus k dt. If you take integration both sides, see, if you take integration both sides, what happened? Then integration sign you are putting, here also integration sign you are putting, then what is the value? R equal to minus kt plus I. Then I is the integration constant. So what is I? I is the integration. This is the integrated value you learn from your mathematics integration, and here R concentration, molar concentration equal to minus kt plus I. Then question is, what is the value of I in terms of the molar concentration? So you should calculate what is the value of I. If take time is 0, then what happen? R equal to R0. So you should take value here, my R0. What is R0 mean? Here 0 order. So what happened here? R0 means here initial concentration. When the reaction going to start, at that time, what is the concentration? That is R, molar concentration 0. So it is called at t equal to 0. When t equal to t, some proper time, then it is R. Are you clear? R means with proper time. R0 means a time t equal to 0. So you calculate the value. R0 here equal to minus 2 into 0. Why 0? Because here 0 order reaction. So here to the power. So it is equal to 0. And plus I, then I equal to, what is the I value here? R, molar concentration 0, that is initial concentration. That means you are calculating the value of I in terms of reactant, and that value at time equal to 0. Are you clear? So put this value in the main equation. What is the number of equation? This one, K, R equal to, so here R equal to, see here, R equal to KT plus I. I value you know, and this value. So you check here, after putting the value, R equal to KT, R0. R mean molar concentration of R. R0 mean molar concentration of, that is a time equal to 0. So you put the value, then KT equal to R, that is 0 initial concentration, and minus R at the time t. So K equal to what happened? K equal to 1 by t, and here R0 minus R. You should put molar concentration sign, otherwise it has no meaning. So R0, that is initial concentration of the reactant, and it is R equal to final concentration of reactant. That means at here at a time t equal to 0, at a time that is equal to t. So this is the molar concentration regarding as R0 and R. If we make a plot, you plot the graph between R mean concentration of reactant, and against T, you can put here R here, this like this. Against T, get a straight line with slope minus K, 0. 0, what is 0? Why you are writing 0? 0 mean that rate constant of 0 order. K1 mean rate constant of first order, and that intercept equal to, this is called intercept value. This portion is called, this portion here to here, this is called intercept value that is equal to R0, and here slope mean K equal to minus slope of the line, and this is concentration of reactant, this is time, and this is the graph, very important graph. Rate constant K0, that mean zero order, can be calculated if you know the value. See, rate constant K0, if you know how to calculate, if you know the initial concentration, final concentration at time t, then and time, if you know at any time, you can calculate K0. Are you clear? Rate constant, that is for zero order, that is K0, how can you calculate if you know the initial concentration and final concentration? So you can see here, again I am going to explain properly. This is a straight line I told just now in the form of y equal to mx plus c, and here what is slope? Slope equal to minus k. Slope in here m. Y in mathematics, you know, y equal to mx plus c, and that is as a straight line. It gives a straight line where y is the this one y is the mx plus c. So here concentration, that it is the y part here, concentration, and x part, this is time. So you can write also y mean what? Y mean here concentration of reactant, that is you can write here. And x mean what? X mean here time. If you plot between two, you are going to a straight line. This is also variation of concentration with rate. Concentration and rate. Rate in y-axis. Rate in what you will do? Rate is in y-axis, and rate, and concentration is R. R in what axis? X-axis. If you draw the graph, then what happen? You are getting a line parallel to the concentration axis. This is also indicates, you should remember what are the graphs in zero order, first order, like this. Here you should write y, not y equal to, this should write y axis. What you will write? Y axis, and here x axis. So here you write x axis. X axis t and y axis this, and if you come to second graph, here y axis is rate and x axis is concentration, that means of reactant. So you can see the graph is parallel to the concentration axis. If the initial concentration R, if you see in mathematics, we are going to in mathematics numerical problem, how it will helpful. Initial concentration, that is the initial concentration of R, if A moles per liter and X moles, that is changed to the product, then what is remaining? A minus X. Again see, if the initial concentration of R mean reactant is A moles per liter, X moles suppose get changed to product used, and what is left behind? A minus X. Then what is the time? After time t. So a time starting, that is A time t, concentration is A minus X. So examples of zero order, you can see ammonia with help of platinum catalyst, it gives N2 plus 3S2. From experimental value, it is sure that rate is K NS3. NS3, it should be square bracket. It should be, otherwise it has no value. So this is the concentration, that it is zero order. So a molar concentration of ammonia to the power 0, you know this value is 1, so rate equal to 1. Similarly, S2 plus Cl2, here also you can see K S2 0, Cl2 concentration 0, so again you find here value is K. So this is the simply zero order reaction. I hope you should remember all the formula, all the concept before going to solve the numerical problems. Thanks for watching my video. I am BL Das, that is Vijayalakshmi Das, ex-PGT Chemistry, Kendra Vidyalaya Sangathan. Thanks to all again.